All right, so yesterday we finished with, I think on this slide, I want to reiterate what it is, what it's saying, because it's going to be a huge component to the things that we're going to keep doing. This says triangle FAT, here's triangle DOG. If I just look at angle F and angle D, would you guys agree that they're similar or the same type of parts? They're both angles, right? Would you agree that one of them comes from, or both of them come from separate triangles?
Yeah.
What's the link between those separate triangles? What's the relationship between the two triangles? They're congruent, okay? Because F and D are in the same spot in their names, or matching spots in their names. What word do we use mathematically for that? If they're matching spots or matching parts, say again? Not similar, not congruent, just for matching parts. If I were to put FAT right on top of DOG, F and D match up as the first object, right? What's the word starts with a C for things that match up? Corresponding, okay? So we got corresponding parts that come from congruent triangles, right? You guys agree with that? What's the link then? What's the conclusion that we make about those corresponding parts? What do you know about angle F compared to angle D in that statement? They're the same. They're congruent. So that creates the statement. We're going to use this all the time, okay? Statement that corresponding parts of congruent triangles are congruent. That's exactly what that statement says. If I have triangle FAT congruent to triangle DOG, I know that A and O are corresponding parts. They're corresponding angles. They come from congruent triangles, so them themselves have to be congruent as well. Does that make sense? Basically telling you the individual parts that make up your polygons, if they're corresponding and the polygons are congruent, those individual parts have to be congruent. Okay? When polygons are congruent, the result of that is that the individual corresponding parts are congruent. If all individual corresponding parts are congruent, the result from that is that the polygons are congruent. Okay, so it's a biconditional. I'm going to write this down here in a moment. But we're going to abbreviate this as CPCTC. Okay. A lot of people in the past have thought, well, C stands for corresponding. Oh, they'll read this as corresponding parts to corresponding triangles are corresponding. That doesn't make sense. Okay. Of course, they'll say congruent parts, congruent triangles are congruent. Think about that. Congruent parts of congruent triangles are congruent. Well, that's pretty redundant, isn't it? Okay. Not saying anything new that the corresponding or congruent parts of that phrase stated. So it's got to be corresponding parts of congruent triangles are congruent. That leads me to something new. Now, triangles are a type of polygon. They are our smallest polygon in regards to the number of sides that we come up with. So sometimes your textbook will refer to this phrase as CP, C, T, C. Okay, so I took the T out and replaced it with T, right? So I took triangle out and now I replaced it with polygon. So we can say corresponding parts of congruent polygons are congruent. Today, that's what we're going to work with mostly is congruent polygons. And then kind of pick off their corresponding parts that should be congruent to one another. So you might see a Math Excel, just because I choose information or questions from different textbooks. Some textbooks will use CPTC, CPCTC. Some will use this, just what that author prefers. Give me one